Good day, learners. Welcome to today's mediation of the solutions of functions test written on the 10th of October. Without wasting time, let me share the screen and take you through that test. Here, my name is Hadile Mampolo. Let me take you through the test. So, as I always say, when you answer the math question, especially with all the topics where the diagram will be given, read the statement, because it's not always the case that all is on everything that is on the diagram is on the statement. Read the statement to check what was not indicated on the diagram. In this case, number one, in the diagram, f of x equals to k over x plus p plus q, and g of x equals to log x minus 2 base 3. F passes through a and 0 and negative 3 over 2. F and g have common vertical asymptote. Now, first question, the coordinates of A are, first, if you want to check, the A is the point of intersection of F and G, but now F does not have enough information, but G has enough information. That is why we use G to determine the coordinates of A. Now, remember, A is the x-intercept. You let y to be 0, then you change from log form to exponential form, then x equals to 3. Then A will be 3 and 0. You use the equation that has enough information, which is G in this case. Now, the question number 2 says, find the numerical values of K. Now, as you were given that F equals to K over X plus P plus Q, since now from G you know the horizontal asymptote as X equals to 2, then it means now we know that if X equals to 2 on the equation will be minus 2. then here you put negative 2, then Q is unknown, then K is unknown. Since Q and K are unknowns, then since now, because Q is unknown, K is also unknown, P is known. We know that P is X equals to 2, but you put negative 2 there. Now, when you check this one, when you just check the diagram here, let's just quickly look at the diagram. If we look at the diagram here, let's just make it smaller so that it will fit here. When you look at the diagram, we don't know the value of the horizontal asymptote, and then we also don't know the value of K. Then you have two unknowns in this case. But we know that F passes through A and passes through this X, the y-intercept, which is negative 3 over 2. So it means you're going to make equation 1 by substituting the coordinates of A. Then you make equation 2 by substituting the coordinates of this y-intercept, which is 0 and negative 3 over 2. Now, first, x equals to 2. From G, you find that the vertical asymptote is x equals to minus 2, but P will be negative 2. Now, your x at A is 0, so x at A is 3, then y is 0. Then you substitute to make equation 1. Now you make equation 2 by substituting this y-intercept. Then y is negative 3 over 2, x is 0. Then you say negative 3 over 2, q comes this side. Then you cross multiply negative by negative 2. Then you find the answer is 3 plus 2q is equals to k. Then you make equation 2 by substituting. You make equation 1 by here. which is k is equals to negative q, then this is equation 2. Then you solve them simultaneously. Then now you'll find that by substituting negative q from equation 1 to equation 2, then after you've done that, then you'll find q as -1 and k as 1. So to get k, you'll substitute q into one of the equations. In this case, you substitute to equation 2. So even if you substitute in equation 1, you'll get the same answer. Now, k is 1. 1.3, determine the equation of the inverse. G to the power -1 is the inverse in the form y equals to. Now, if you look at this one, you first interchange x and y. Remember, in this kind of a question, it will be 2 marks. The first mark will be recognizing the inverse. So you interchange x and y, you get the 1 mark for it. Then you get 1 mark for the answer. Even if you don't show the working out here, you'll get the full marks. As long as you interchange x and y, then you get answer correctly. So you interchange x and y. From there, you made y you change the log form to exponential form. Then you made y the subject of the formula. 1.4, the equation of the line of symmetry which does not intersect with the graph. If you look at this, when you talk about the equation of line of symmetry which does not intersect with the graph, you talk about the one with negative gradient. Remember, lines of symmetry can have the positive gradient and the negative gradient. So the one in this case is not always the case that the one which does not intersect with the graph would be the one with the negative gradient. In this case, remember the graph is in this quadrant and this quadrant. Now, so the line which does not have that does not intersect with the graph is the one with the negative gradient. So then you say y equals to -x plus c. Then you substitute the values of the asymptote. Remember the value of x of the vertical asymptote will be x equals to 2, and the value of horizontal asymptote will be y equals to -1. So you substitute them, then you get c, then y would be -x plus 1. But if the question was saying the one with which intersect with the graph, then we'll be referring to the one of the positive gradient. So, but here we want the one which does not intersect with the graph, which happen to be the one with the negative gradient. So the equation of the line of symmetry, which does not intersect with the graph, would be the one with the negative gradient, which is y equals to -x plus 1. Okay. Let's paste it here so that every question we see. Now, if h of x equals to g of x minus 4, determine the domain and the range. First, we know that when you determine the domain of a log graph, your critical value will be the asymptote. The vertical asymptote. Remember, log graph has only the vertical asymptote, not the horizontal. It means this horizontal asymptote in this case is not for the log graph. That is why the graph passes through this asymptote. Now, then you check the vertical asymptote, and then from there you check whether the graph is on the right or on the left. So if it's on the left, you say x is less than the value of the asymptote. If you say it's on the right, you say x is greater than the value of the asymptote. So in this case, our vertical asymptote is x equals to 2. Then you'll say, because the graph is on the right of the asymptote, then domain will be x is greater than 2. Now, h of x is equals to g of x minus 4. It means to obtain h of x, G is translated 4 units downwards. So the vertical shift does not change the domain. Remember, the vertical shift does not change the vertical asymptote. So G minus 4 does not have any impact. Shifting the graph 4 units downwards does not have any impact on the domain because the vertical asymptote stays the same. Therefore, the domain will just be x is greater than 2 because the graph is on the right of the asymptote. So this vertical shift of minus 4 does not change the asymptote. The asymptote will still be x equals to 2, then domain is x is greater than 2. Now, when coming to the range, we know that the log graph does not have a horizontal asymptote. So the domain of any continuous log graph, the range will be from negative infinity to positive infinity. So meaning that the range that is not restricted, the range is from negative infinity to positive infinity because the log graph does not have a horizontal asymptote. It was only the vertical asymptote. Just like when the exponential graph does not have a vertical asymptote. So the log graph does not have a horizontal asymptote. So the domain will be x will be greater than 2. The range will be y will be an element of real numbers. Now 1.6 says, let me just cancel this one here. Now 1.6 is say f of x equals to x plus k. If f of x equals to x plus k, find the values of k for which for which the equation will have two unequal roots of opposite signs. Now f of x, we know it. Then from here you'll find x minus 2 as our LCD. Then you multiply everything by x minus 2. Then when you multiply here, they will cancel, we remain with 1. Here we'll have negative 1 times x minus 2. Here we'll have x plus k times x minus 2. Then we clear the brackets. And when we clear the brackets, you have this. Then we write the equation in a standard form. Remember, you can only factorize when your equation is in a standard form. Now, or you can only use discriminant when the equation is in a standard form. Then what you will do in this case, you will say if you take negative x to the other side, it will be positive. Negative 2x plus x will be negative x. Then when you take x as a common factor, you have k minus 1. The reason you are doing this, you want to write the equation in the form of ax squared plus bx plus c. So since you have two terms, which is minus x, after you transpose this one to be kx minus x, then you take out x as a common factor because these two terms have x. Then you take 1. You see 1 plus 2 is 3. You take 3 to the other side, then it will be minus 3. Then you write your equation in a standard form. Now, if we say for which the two graphs will have two roots of opposite signs. Now, in any quadratic, you can only have opposite signs if A and C have the opposite signs. So meaning that since A is positive, it means C must be negative for us to have the roots of opposite signs. So that is why we'll say the C which is minus 2k plus minus 3. Remember, k is anything which does not have x. So minus 2k minus 3 is our c. Then you say it's less than 0. Remember, anything that is less than 0 is a negative. Why do you say it's negative here? Because already a is positive. So for us to have the roots of opposite signs, a and c must have opposite signs. So that is why c must be negative, because already we know that a is positive. Now, when you take 3 to the other side, it will be positive. Then when you divide by negative 2, remember, when you divide by negative, inequality sign will change. So then k will be greater than negative 3 over 2. If k is greater than negative 3 over 2, then we'll have 2 roots of opposite signs. Now, we go to question 2. As we did in the first one, you read the statement. In the diagram, f of x is equals to k over x plus p plus q, and g of x is equals to minus 2x squared plus bx plus c. And then the equation of the lines of symmetry of f are y equals to negative x minus 1 and y equals to x plus 5. F passes through a with the coordinates 0 and 10 over 3. The x-intercepts of f and are d and e. B is the y-intercept and c is the turning point of g. The vertical asymptote of f is the same as the axis of symmetry of g. You can see we mean this line here is the vertical asymptote of f and also lines of symmetry of the parabola. Remember, line of symmetry cuts the graph into equal parts. Now the value of the x value of the line of symmetry of parabola would be the same as the x value of the turning point. So 2.1, the equation of the asymptote of f are, remember, if you are given the lines of symmetry, both lines of symmetry, you can use them to determine the asymptotes. The reason being that lines of symmetry intersect where the asymptotes intersect. So then you solve them simultaneously. You find that x is minus 3. Then to get y, you substitute to one of the equation. Whether you substitute to this one or this one, you get the same answer. Then y will be 2. Then this will be lines of symmetry. So even if in a question you are given the equation of one line of symmetry and one asymptote, you use the given asymptote, you substitute the given asymptote, the value of the given asymptote to the line of symmetry, then you'll get the other asymptote, because lines of symmetry intersect where the lines of symmetry intersect with the asymptotes. 2.2, the numerical value of k is, to find the numerical value of k. Now, if you see, I put this on the separate sheet so that we enlarge it so that you see. So f passes through. Remember, if you are given unknowns in an equation, you look at the graph, you check the values that you know for that graph. So in this case, hyperbola passes through 0 and 10 over 3 and also passes through D. You can't use D because for now we don't know what D is. You'll use this point because it's where the hyperbola is passing. It passes through 10 over 3 and 0. So that's why y is 10 over 3, x is 0. Then you take 2 to the other side. 10 over 3 minus 2 is 4 over 3. Cross multiply 3. Then you'll get k as 4 because 12 over 3 is 4. Then the numerical value of k is 4. Then let's quickly go to 2.3. Hence or otherwise, the numerical values of b and c are, remember, in the equation you were given that g of x is negative 2x squared plus bx plus c. Now, first, we will say, if you look, let me just quickly go to this page. If you check this, For this parabola, you only know x, which is the line of symmetry, or the axis of symmetry. Remember, the axis of symmetry cut the graph into two equal parts. But we know that here, the value of x as minus 3. You know this one as minus 3. How did you get minus 3? Is by calculating. If you check, let's quickly go back here. From the previous question, you determine the value of k, and thereafter you determine the value of the value is here. You use the lines of symmetry here. Then you found that the equation of the vertical asymptote is minus 3, and in the statement we said the vertical asymptote is the same as the axis of symmetry of the parabola. So it means for the parabola in this case, you only know the line of symmetry, which is here. Let me quickly go back here. Yeah, now we know that the equation of the axis of symmetry is x equals to -3, which cut the graph into two equal parts. So, but we don't know d and e. But we know that if we can determine one of them, we'll use the midpoint formula to get the other. Because C, this line of symmetry is at the midpoint of D and E, as it cuts the graph into two equal parts. So we have to determine either D or E. But in this case, we can't find E, because E does not intersect with the hyperbola. Remember, always use what you know to get what you don't know. So in this case, because D is the point of intersection of hyperbola and parabola, that is why we use the equation of hyperbola that you already determined to find the coordinates of D. So first we'll say at D, so the hyperbola is this one. Now it means now you are going to use you say at D, first let's go back here. Now hyperbola is this one, and then we know that D is the x-intercept. Since it's the x-intercept of this hyperbola and parabola, you let y to be 0. If y is 0, we'll have this, and then and then this will be a 0. 2 will come this to this side. Here it will be +2, because it's the equation of hyperbola. Then you take 2 to the left, then you cross multiply, then you'll get the answer x as -5. So it means the coordinates of D are x is -5 and 0. Now, since we know that x here is -5 and 0, and then the axis of symmetry is -3, and we know that axis of symmetry cut the graph into two equal parts, so it means this axis of symmetry is at the midpoint of D and E. Then we go back here. Then we say x -5. Remember, this x is x of E, which we don't know. -5 is x of D over 2. We are using a midpoint formula. That midpoint, we know it, which is -3. -3, remember, is the axis of symmetry. Then you cross multiply, then you have -6. Then x will be -1. Or by inspection, you will know that if the axis of symmetry is -3, you see from -3 to -5 is 2 units. So from -3, you must also count 2 units to the left. That is why x will be -1 there, because it's at the midpoint. Now, then you'll have the equation here. You'll have the equation of G. Since now you know the x, the x-intercept, you'll use A into, you'll do this. You'll say Y equals to, you'll say, you know the formula for finding the equation of, you know the formula for finding the equation of parabola. If you know them, if you know the intercepts. Let me just quickly write it down. You know that this is the equation. Let me just type it quickly. So you know this from grade 11, but I just want to remind you, this is the equation is x1, and then here is x2, but in this case it's easy because already you were given that the equation of G is minus 2x squared plus bx plus c. It means A was given. It means I've given the value of A. So it will be like this, but now because A is known, then it will say it's minus 2, then x1 will be minus 5, will be minus 5, will be plus 5. Here x2 will be minus 1, then which is then when you clear the brackets, you'll have the answer as negative 2x squared minus 12x minus 10. Then it means B is minus 12, C is minus 10. Then 2.3, we'll go to determine the coordinates of C. Let's check where C is. C, where C? Oh, C is the turning point. Let's check where C is. C in this case, it is the turning point. We know that already. We know the x value of the turning point, which is x equals to minus 3. So we know that to get the y value of the turning point, you substitute the x value to the original equation. The equation of G, we have determined it here. Then we substitute x as negative 3, then the answer will be 8. Then the coordinates of C, the turning point of G, is minus 3 and 8. Now, 2.5, find the values of x for which f of x times g of x is greater or equals to 0. Remember, anything that is greater than 0 is a positive. Then you can get positive when you multiply positive by positive. So, in other words, you want the value of x on the graph where you will get positive answer when you multiply, positive answer of 0 when you multiply y of f and then y of g. If you look at this graph, you can see that you will check where one value is negative. They are both negative, they are both positive. Remember, you can only get a positive answer when you multiply positive by positive or negative by negative. But we don't have a case where both the graph are on the negative values. So like here, if you check from here, y is positive, here y is negative, and positive times negative is a negative. But you don't want negative, you want where there will be positive. And also here, positive by negative, it is a negative. Positive by a negative, it is a negative. So it means here is also not the solution. Now, we want where both y's will be negative or both of them they will be positive. Then the only part where you'll have our solution is between our asymptote and E. Is between our asymptote and E. It is between our asymptote and E. Now, if you check in this case, here y of f is positive and y of g is also positive, then you say between -3 and E. So then you will say between -3 and E. But now, if you check in these two, I left the space so that I'll clarify this. You check that we want where is positive or 0. Now, if you check at this point, this side is negative, but here it is 0. Then we'll say it will say between -3 and -1, and where x equals to, not where x is less than or greater. Here it will be 0 because we say where is greater or equals to 0. So then let's just put this here. I left the space so that when I explain you'll understand what I'm talking about. So between -3 and this one is not a solution because -3 is the asymptote and it will not be part of the solution. Here between -3 and 1, it will be the solution here, but we say or where x is equals to, or where x equals to, or where x is equals to negative is equals to -5, because at -5 x equals to 0, because we say where is greater or equals to. Let me just also put it here so that I don't put in one value and then one will be in a position to pick that up to say there is a gap. So now it means in this case the answer will be a B, because now here we will not say where x is, it means this -3 is excluded because is an asymptote. Then it means the answer in this case it will be a B. The answer in this case will be a B because -3 is not part of the solution, as is the asymptote. 2.6. If f of x is equals to -2x squared minus 12x minus 10, use the graph to determine the values of k for which -2x squared minus 12x plus k equals to 0. Let us I did this deliberately because you may find that in a question they say find the value of b and c, as we did. Then in the question, maybe the next question, they say if f of x equals to, you must know that these values are the ones that we're supposed to get in number in the question where we are calculating b and c. But if these values are not the same, you go back and check your calculations to see if, because they can say if b and c is b is -12, c is -10, if they are not. When they are not, so they will always say if this equals to this. This will be the correct values that we are supposed to get. So I'm just giving you tips to say if you calculated the values and then in the next question they say if b equals to this or c equals to this and c equals to this, you must know that these are the correct values. Now determine the values of k for which this will be equals to 0. Will have 2 negative roots. Let's check. Here we say -2x squared minus 12x plus k equals to 0. Now, remember we have to use the graph to determine those values. But the equation of the graph is not minus 2x squared minus 12x. It's minus 2x squared minus 12x minus 10. It means we miss minus 10. For us to use the graph, we must have minus 10 here. But remember, there's nothing wrong when you do that as long as what you do on the left, you're doing it on the right. You put minus 10 this side and this side. It's like we did nothing, because if you put minus 10 to the left, 10 minus 10 would be 0. So we put minus 10 so that we have the equation of the graph. Now, then it means now you are checking the values of x. Then you say, when can you have, if now you found the equation of the graph, when can you have two negative roots? Look at the graph. You can only have two negative roots. If you draw a horizontal line on the graph of this parabola, you can have two negative roots anywhere between B and the turning point. Remember, between B and the turning point, you see between B and the turning point. Remember the turning point, y. Remember when you say minus 2x squared minus 12x minus 10 is equals to y. So y is between, here is 8. Then if you find the y-intercept will be minus 10. Or remember, y at b is minus 10. Remember, when you say two negative roots, it means where you'll get two negative x values when you draw a horizontal line. If you draw a horizontal line here, x here will be negative, x here will be negative, x here will be negative. We have two negative roots anywhere between the turning point and the intercept. Below the intercept, we are no longer having two negative roots. We have a positive root. X here will be positive, x here will be negative. The negative roots, you can only get them between the y-intercept and the turning point. So that is why I will say between this minus k minus 10, which is the same as y. Remember, this equals to y, and then it means this is also equals to y. But we can only have the negative roots between negative 10, which is the y-intercept of the parabola, and the 8, which is the y value of the turning point. Then when we take negative 10 this side, it will be positive. Then you have 0. Then we'll take this. Then it will be 18. Now remember, when you divide by negative, is either you change the inequalities or you swap the number. So minus 18 will come this side, 0 will come this side when you divide it by negative. So between, let me change it here. We don't want the values of x, we want the values of k, for which the graph will have two negative roots. Then k will be between negative 18 and 0. Number 3, let me also, as I did with this one, let me take the graph to this side so that when you calculate, you can see clearly what. Take it to the other side. Let me make it bigger. Now, let's read the statement. As we are given the statement here, in the graph below, in the diagram below, f of x is equals to a to the power x plus q. It's exponential, you can say that. G of x is mx plus c. The equation of the horizontal asymptote of f. Let me just quickly cut this one. Let me just quickly cut this one. Now, let's put it here. Okay. Now, let's read the statement again. In the diagram below, f of x equals to a to the power x plus q, and g of x will be mx plus c. The equation of horizontal asymptote of f is y equals to minus 8. F passes through a, b, and c. And c, the coordinates of t is 2 and minus 31 over 4. dq is perpendicular to the x-axis. We know that whenever the line is perpendicular to the x-axis, it means x does not change anywhere. It means if we know that if OA is 2 units, we know that x this side, OA is, let's say, we'll say OA is 3 units. We're supposed to say OD, not OA. OD is 2 units. Let's change it. OD is 2 units. Now, if OD is 2 units, we will know that it means x here is -2, because x this side, it cannot be positive. But we know that distance can never be negative. You can say OD is -2 units, but the position will make x to be -2. As we are seeing, what I'm talking about is this. I wanted to show that you see. So if you check what I'm trying to say here, we said OD is 2 units. If it's 2 units, you know that x this side, it cannot be, x this side cannot be positive. So x will be negative, but the distance is 2 units. It's not -2 units. Distance can never, or the length can never be negative. Now, let's go to the first question. Find the numerical value of A. You check what you know. We know that the graph of A passes through point 2 and negative. It passes through this point 2. It passes through point 2 and -31 over 4. So then you use this point to calculate the value of A. The horizontal asymptote, it was given as -8. Horizontal asymptote, it was given on the statement as -8. If horizontal asymptote is -8, so you put it here, then you substitute the values. Remember, x is 2, y is -31 over 4. When you take 8 to the left, 8 minus 31 over 4, it will be, remember 8 when you take it to the left, it will be positive. 8 minus 31 over 4, it will be 1 over 4. Then it means A would be the square root of 1 over 4, which is half. Remember here, you can't say plus or minus. Whenever exponential graph is above the asymptote, it will be positive. If it was below the asymptote, we'll say the answer is -half. So it's above the asymptote. So A can only be negative when the graph is below the asymptote. So here the graph is above the asymptote. The value of A, we got it, 3.2. The equation of G is, remember G is the linear. Then the linear passes through which points? The linear passes through B, and also it passes through A. It means you are going to find the coordinates of A and the coordinates of B to find the gradient, because the line passes through where, or I can say the x-intercepts, the intercepts, both x and y. The intercepts of the linear are the same as the intercepts of the exponential. Since we determined the equation of the of G. Oh, sorry. Since we determined the equation of F, we can use it to determine the gradient of the coordinates of the intercepts, hence the gradient of the linear. Then you find the equation of the linear. So first we determine the coordinates of A. A is the x-intercept. You let y to be 0, as A is the common x-intercept of both exponential and the linear. Then x is -3. Then the coordinates of A would be -3 and 0. To get the coordinates of B, just let x to be 0 because B is the y-intercept. Then 2 to the power 0 is 1. 1 minus 8 is minus 7. Then the coordinates of B will be 0 is to minus 7. Then it means the gradient of AB will be changing A over changing B. The y of A is 0, y of B is minus 7. You see minus 7. X of A will be at minus 3, x of B will be 0. Then the answer will be negative 7 over 3. And we know that the y-intercept of a linear is always the c. Here there's no need to calculate the c, but if we didn't know the y-intercept, we'll substitute one of the coordinates on the equation of mx plus t to get c. So, but here always know that the y-intercept will be of the linear will be the c of that linear. Then the equation will be negative 7 over 3 x minus 7. 3.3, determine the length of PQ. Remember, PQ is the line between the linear and the exponential, and then since it is parallel to the y-axis, remember when the line is perpendicular to the x-axis, then it's parallel to the y-axis, x does not change. It means that since we're given that OD is equals to 2 units, it means the x of d will be negative 2. So it simply means that first you will say the equation of the linear that you calculated here minus the equation of the exponential. Remember this one inside the brackets is the equation. This one inside the brackets will be the equation of the linear. So of the exponential, and the reason why we say linear minus exponential, we know that linear is on top. Then you will say the PQ is the equation of linear minus the one of the exponential. If exponential was on top, if it was the line was here, you say exponential minus the linear. So you always say the one on top of that line minus the one at the bottom. In this case, linear is on top. Then you will say the equation of the linear minus the equation of the exponential. Then from there you substitute x as negative 2, because on the line of line PQ, x is negative 2 everywhere. Now when you calculate, you use your calculator. Let's quickly calculate. You say minus 7 over 3 into negative 2. Then you say minus 7 minus into, then you say minus 2 minus 2. Then remember here you'll say remember our equation here. Let's just do it. Our equation of exponential was the equation of the exponential was the 1 over. Let's just quickly go to this. We know that when we were calculating the equation, a was half. If a is half, half is the same as 2 to the power minus x. It means now, let's go back here quickly. So it will be 2 to the power minus x minus 8. Then you'll say 2 minus into 2 to the power minus into minus 2, which is plus 2. Then you say minus 8. And then you say minus 8. If you say minus 8, the answer will be 1,67. The answer will be 1,67. The answer will be 1,67. Now 3.4, determine the equation of f to the power minus 1 in the form of y equals 2. As we did, we know that here we're referring to the the inverse. The inverse of logarithm is the log. Sorry, the inverse of logarithm is the exponential, of exponential is the log. So first, as we did with the log, you interchange x and y first. So from there, you make y subtract. I mean, 1 mark will be for interchanging, 1 mark will be for the answer. So even if you just go straight from, you interchange and get the answer, is fine. But here I'm just trying to show you how we did that. So we put log both sides. So here we applied law 3 of logs, which is no longer examinable. So say minus, here we'll have a minus y. If you have minus y, then you put it here. But in a nutshell, you will know that the vertical asymptote will tend to be the horizontal asymptote of the exponential will be the vertical asymptote of log. It will be x equals to minus 8. But we know that for log, if this minus, then you put plus to make it easy. The base will be the same. If the base here was 2, the base will also be 2 here. But the negative will come this side, because log 3, it means if you have a log, here is the exponent, then you can put it here. So this is log 3, which is no longer in the syllabus, but I'm just making it easy for you to say, you look at the horizontal asymptote. If horizontal asymptote was minus 8, then on the log it will be the vertical asymptote. It will be x equals to minus 8. But we know that for the log, if the asymptote is minus, you put plus, but it must also be in brackets. Then you get the answer as the equation of the, here it will be the equation of the inverse. The inverse of exponential will be the log. The base will be 2 there. 3.5, the values of x for which the f at the inverse at x, the inverse of f at x is greater than 2. You just do that. You can just use the graph, but if you see that it can give, you can calculate, you'll just say it's greater than 2, change from log form to exponential form. This 2 will come here and make this minus 2 to be exponent. Then you'll say x, 8 will go that side, it will be minus 31/4. You can see that it was is what was the y value. This is what was the y value. Is what was the y value of the exponential graph when x is 2. You can calculate. If you feel that using the graph can be a challenge. But if you are using a graph, you will just look at this and say, since the inverse, you treat x as negative 31/4 and y as 2. But first you say, okay, let's look at this. You say, if the graph is below negative 31/4, the graph below negative 31/4, where does the graph go? Or when you say, because we were saying where the graph is, let me just go back to the statement here. You say where the graph is greater than 2. So for greater here, for greater it means above. Above, the graph is going to the left. Above this negative 31/4, the graph is going to the left. So then since we are treating this negative 31/4 as the x now, then you'll say x is less than negative 31/4. But to be on the safe side, you must just calculate. If h of x is equals to 2 to the power x plus 8, describe in ways the transformation from f to h. Since x changed sign, it was negative x is positive x. It means it's a reflection on y, about the y-axis. Since we had 8 instead of, but if the sign changed here, we'll say reflection on x-axis, because you divided the plot by negative part. Because the base didn't change sign, it means only this part changed. So it means you can only get 8 from negative 8 if you add 16. It means the graph was reflected on y-axis and also shifted 16 units, translated upward by 16 units, translated upward by 16 units. So it was translated upward by 16 units. So it means in this case, the correct answer will be C, reflection about the y-axis and translated by 16 units upwards. So as long as X changed sign, it means it was a reflection about the y-axis. 3.7, 3.7, the values of X for which the derivative of F is times G of X is less than 0. Derivative is the gradient. It means when you multiply the gradient of F times y of g. Remember here there's no prime. This means for g we're referring to y. You must get a negative answer. It means one must be positive, the other one must be negative. Now, if you check F is a decreasing graph. If it's a decreasing graph, it means the gradient is negative everywhere. If the gradient is negative everywhere, it means for us to get a positive answer when we multiply, we will check where g is positive. Because remember, when you multiply two things to get a negative answer, is when one is positive, the other one is negative. So, but in this case, already we know that F is decreasing. It means the gradient of F is negative everywhere. So it means you are going to check where G is positive. Let's look at this. Where G is positive, where is G positive? G is positive here. It means when we say where g of X is positive, we mean where y of G is positive. Y of G is positive on the left of A. On the left is going, and X here is negative 3. So we say when X is less than negative 3. So when X is less than negative 3, the Y will be positive and the gradient is negative. But here, the gradient is, you know, that as I said, gradient is negative everywhere, but y here is not negative, it's positive. Y is only negative when X is less than negative 3. So it means the answer here, the answer is B, where X is less than negative 3. Number 4. There's no need to take it to the side because the diagram is smaller, it doesn't have many things. In the diagram below, f of x is equals to ax squared, and then f passes through 2 and minus 12. Now, it's easy. The graph passes through 2 and minus 12. For us to get a, you substitute this values, minus 12 and 2, then a will be minus 3. 2 squared is 4, then you divide that by minus 12 by 4. Then the answer will be negative 3, which is D in this case. The equation of the inverse is equals to so if you want to write this in then you'll see x equals to, remember inverse first thing, you'll get a mark for recognizing the inverse thing. You interchange x and y. Now, if you want to make y the subject of the formula, you'll first say you divide by negative 3, then it comes to this side. Now, if it's like this, then it will be restricted, because now the square root of a negative is not admissible. It's imaginary. So now it means not all the x values will hold. So this will only be valid when x is negative, because negative times negative is a positive, when x is greater or equals to 0. So meaning that this will be valid when x is less than. Now, The reason why the correct answer is this one is that 0 is included. If this is 0, this will still be valid. It will still be valid because the square root of 0 is a 0. But this, for this to be valid, for this thing in to be greater or equals to greater or less than 0, less or greater, sorry, less or equals to 0, I mean to say less or equals to 0. If x is a negative answer, negative by negative will be positive. So this will be valid. So that is why we say the answer will be this one. It will be this one, plus or minus. But when x is less or equals to 0, therefore the correct answer will be a B in this case. 4.3, if f is restricted so that the inverse will be a function, which one of the following options is correct? F should be restricted in such a way that it is 1-to-1. In such a way that 1-to-1 relation is obtained. 1-to-1 relation is obtained. So remember, if it's an inverse, in this case, it will be many to. Remember the graph, this f is many to 1. And any graph which is many to 1, its inverse will not be a function. It will not be a function because the inverse will be 1 to many, which is not a function. So now, if we cut this graph at the turning point, if x is less than 2, if we make x to be less than 2, the relation will be, so here the question says, if f is restricted so that f to the power negative 1 will be a function, which one of the following is incorrect? Let's check. If you cut this graph, if x is only from here to negative infinity, when you draw horizontal line here, we will still have two outputs, two inputs for one output. So this will still be many to 1. If it's many to 1, its inverse will not be a function. So the only way for us to make it 1-to-1 function, to make it 1-to-1, if you cut it here at the turning point, whether you say x is less than 0 or x is greater than 0, it will be 1-to-1. If it's 1-to-1, the inverse will also be 1-to-1. Any graph that is 1-to-1, its inverse will be 1-to-1, and it will be a function. So it means the correct answer in this case, it will be the correct answer here, it will be C. Why is it C? Because we are not saying which one of the options is correct. Which one of the options will be incorrect? So it's incorrect because if x is restricted to be less than 2, it will still be 1 to many to 1. And if it's many to 1, its inverse will be 1 to many, which will not be a function. So if we want to achieve what we want to achieve by making this in such a way that inverse will be a function, x to cut the graph at x, to restrict it to be for x to be less than 2 will not achieve what we want to achieve. That this will be incorrect. It's incorrect because if you restrict f in such a way that x is less than 2, its inverse will not necessarily be a function, because it will be 1 to many, and then 1 to many is not a function. Number 5. In the diagram, f of x equals to ax squared plus bx plus 5 over 2, and g of x is equals to mx plus c. The coordinates of the point of tangency are 2 is to 6, and the angle of inclination of G is 135. We know that if you are given the point of tangency, at the point of tangency, gradient x and y are equal for the two graphs. At this point, gradient is the same, x is the same, and y is the same. Now, since we know the angle of inclination of this graph, we use it to determine the, the gradient of the linear. The gradient will be -1. If gradient is -1, it means here is also -1. And then at the point of tangency, gradient is the same. And then we know that gradient is the derivative. Then what you do, we'll, say f of x equals to, we'll say f of x in this case equals to ax squared plus bx plus 5 over 2. Remember, this is the derivative. The gradient is the derivative. Then you say the derivative is 2ax plus b, but we know that at this point of tangency, gradients are equal. Then the derivative will be equals to -1. Then you substitute the x value of the point of tangency to make equation 1. Then you substitute the x value. I think here it was supposed to be 4, not 5 over 2. I don't know whether it's 4. Now, if it's 4 here, then you will substitute both the points of tangency here to get the equation 2. Then our equation 2 will be 4a plus 2b equals to 2. You can write in a simplest form to be 2a plus 2b equals to 1. Then be 4a minus this is equals to 2 is equals to 4a minus 8a minus 2 equals to 2 minus 4a is equals to 4. Then a equals to -1. And to get b, you can just substitute a as -1 to one of the equations. Then you get the value of b, which is 3 in this case. Then a is -1. Let's quickly check. Let me put them. I didn't put the options here. I'm happy that I worked this out before I gave the test to you. Now we'll say a and just say a here. Let's say a. We can put -1 first here. -1. You can put -1 first here. Then the b is a, also b is this. So, like I'm saying, it's good that I'm working this out before you write test. A is this. Let's say I'll make this correct answer, A to be the correct answer. I'll play around the change others. So here I can just say 1. Then I say B. Let's say C. Let's say A. I also put minus here. Efficiency. Let's just quickly put this. Then from them, we can just say D. That we're good to go. Then our answer here is A. So here I can just put a different answer here. Say 4. Then we're done. Then our correct answer in this case will be A. Okay, we go to number 6. In number 6, in the diagram below, the equation of the line is 3y plus x equals to 0. We see that this is not a continuous line. It is an endpoint. This is shaded. This is a hole. It means it's not, x is not the element of real numbers. X is between -6 and 3, including -6, excluding 3. Now, the domain of the inverse. So first, for us to get the domain of the inverse, remember, for the inverse, the critical values of the range will be the critical values of the domain, and vice versa. So it means here, we'll say the range, the y value is 1, the x value, the y value is 1 and -2. So meaning that when x is -6, y is 1. When x is 3, y is -2. It means for the domain, these critical values for the range of f will be the critical values of the domain of the inverse. then it means x will be between -2 and -2 and 1. But now I know that deliberately I did this because one will say, because for the domain of f, this is included, then this is also included. No. Remember, when x is -6, y would be 1. So that's why 1 would be the one that is included. Then the correct answer in this case is a B. Sorry. 6.2. The equation of the reflection of line 3y plus x plus 3 equals to 0. Remember, the equation of the reflection of line, of this line on line y equals to x. Reflection on line y equals to x is the same as the inverse. It means you interchange x and y, then you make y the subject of the formula. Then the correct answer is A. The last one, f of x is equals to ax squared plus bx plus c, has the following properties. If both a and c, now a is less than 0, b is greater than 0, and c is less than 0. Which one of the following graphs has the given properties? Now, we know that when you factor, if a and c are both negatives, the both x values on the graph will take the sign of b. So since b is positive, then it means x and y will be positive. And then if a is less than 0, the graph is a set phase. So meaning that the graph must be set phase, and both x and y must be positive. So in this case, it means the correct answer will be A, D, because it's a set phase and both x values are positive. Let us thank you so much for watching. I know that it was long, but with technology, I like the fact that if you didn't get one of them right and you are not sure about one, you will move it fast to get to the end. If it was toward the end, if it's the middle, you move it to the middle and get only the part that you did not understand. Please encourage others to subscribe. So thank you for watching, and then don't forget that for you to pass, you need to study all the subjects. So follow your study timetable. Make sure that every day, the whole month of October, you must be reading at least one subject. Have at least 1 hour per subject. So when the exam comes, you will not have challenges. I close this by saying, if it didn't happen in the third term, it does not mean that it will not happen this term. Just fire all your cylinders. God gave you the last chance. Just use it to the best of your advantage. Prioritize your activities. Make sure that leisure time, you put it aside. You will have the whole December for leisure time. So fire all your cylinders. You have only one opportunity to write the final exam. Do your best. Use every resource you have to succeed, to do well in your final exam. Thank you so much for watching.